Okay, let's try another one. If we do the quotient rule on this, for my first derivative, I get low. D high is 6x minus 1 minus high. D low is just 1 over low squared. So if I distribute, I'm going to get 6x squared minus x, and since I'm only multiplying by 1 over here, I can go ahead and distribute this minus, and I get minus 3x squared plus x minus 1 all over x squared, which becomes 3x squared minus 1 over x squared. Now, when I look at this, I don't see anything that simplifies. However, I do see that I started with a single term in the denominator. We're going to look at that in a minute. If I want to do the second derivative, we need to take the derivative of 3x squared minus 1 over x squared. And so I will get low, d high is 6x minus high, d low is 2x over low squared is x to the 4th. So I get 6x cubed. If I distribute the 2x and the minus at the same time, I get minus 6x cubed, and minus a negative here is going to be plus 2x all over x to the 4th. So I get 2x over x to the 4th, which will simplify to 2 over x cubed. Now, when I look at my first derivative, I see that there was a single term in the denominator, and I see that I did simplify my answer. What if, from when we started, with y equals 3x squared minus x plus 1 over x, we had separated all the fractions. Well, we'd have 3x squared over x, that's just 3x, negative x over x, that's minus 1, plus 1 over x, we can write that as plus x to the negative 1. Then my first derivative would have just been a power rule problem, and I would get 3, derivative of negative 1 is 0, derivative of x to the negative 1 is negative x to the negative 2, and our second derivative, 3 goes to 0, negative 2 comes out front, we get positive 2x to the negative 3, which is the same thing we got doing it the long way. So it really would have benefited me to have paid attention to the fact that I had a single term in the denominator to start with, and I never would have had to use the quotient rule at all. All right, this problem is going to be a product rule. I've got e to the t times sine t. So my first derivative is the derivative of the first, that would be e to the t, times the second function, which is sine t, plus the first function, e to the t, times the derivative of the second function. Derivative of sine is cosine. Now, when I take the derivative of this, I see two product rules. However, this matches our original function. So I already know what the derivative of our first term is. It's e to the t sine t plus e to the t cosine t. So that's what this turned into. And now we need to take the derivative of the second part using the product rule. So the derivative of the first function is e to the t times the second function, which is cosine t, plus the first function times the derivative of the second function. Derivative of cosine is negative sine t. Now let's rewrite this so that we can combine some like terms. This is e to the t sine t. Here I see 2 e to the t cosine t terms. And then we have minus e to the t sine t. So e to the t sine t minus e to the t sine t goes to 0. And our answer is just 2 e to the t cosine t. Okay, so we did a lot of second derivatives there. Let's go further and find a fourth derivative. So our function is y equals x squared plus 3x to the negative 3. All of these derivatives are going to be power rules. So my first derivative is 2x. Negative 3 comes out front, and I get negative 9x to the negative 4. My second derivative is 2 plus 36x to the negative 5. My third derivative, derivative of 2 is 0, and so I get negative 5 times 36 is negative 180 x to the negative 6. And finally, my fourth derivative, negative 6 comes out front, and negative 6 times negative 180 is 1080, and we get x to the negative 7.